Hey, this is Zach Julian, and this is my code that's emulating a bash shell for Assignment 2 in the Operating Systems class. Here we have Microsoft Azure pulled up, and as you can see by um, the name here, this is my personal terminal. There's not much here. It's not a full system, but it does serve our purposes here today. So I coded mine in C++, and I will pull up that code now. So if I just type in vi zacode.cpp C++, and here we go. This is my code here. It's 67 lines in total, and let me run through it here. So we're including all of these classes: the IO stream, the uni std, and the wait class, which is important for the parent processes, as we'll talk about later. So as you go into the main, you have the PID ints and the status, which is important, and then you fork the processes. Both of these are basic in executing parent and child processes, which is how operating system terminals um, execute their processes, like execute their commands, actually, like changing their directory and showing everything. And here we have a boolean active that's always going to be true. That's because when you're in the terminal, everything is going to be running. So basically, I have that boolean on this while loop, so that means this is always going to be running. It never is going to stop. The only way to stop it is by hitting Control C, which cancels the execution of the code itself. And after that, we define our strings. We have the input, the command, and the argument. And what that's going to mean is down here we have our cin, which is input. It's all going to be put into this string called input. And that input is going to be parsed twice. So first, we are going to find the position where the space occurs. So the character we're looking for in this find is the space. So that indicates that the command has passed and we've now moved on to the arguments. So basically we're finding where that junction is, and we're taking that index and we are making a substring to separate the command from the argument. And that's important for our if statements. So we take the full string, the input string, and we take the index of the position of the space minus 1. Because strings run in a 0, 1, 2, 3 type of position, and because of how the substring works in C++, you start the substring at the index of 0 and add, and the second argument is how many characters you add to it after where you start. And it's position minus 1 because if I were to include the 1 that's taken off, we would have the space inputted. And we don't necessarily want that. Wouldn't be the end of the world, but we don't want that. And then we have the arguments, which is basically the same thing, but in reverse. We take a substring, and then we only have one argument here. It's where the space is plus 1. So that means we get everything to the end of the substring past this point. So the space is never included. We don't really care about the space. I mean, we care about it in that we use it to find everything else, but we don't use it in any of the substrings. And the reason the command is important for our if statements is because, as you'll see here, we go down the list and we search for every command that should be available to the user. The remove command, the cat command, the vi, the pwd, the ls, and the cd, change directory. So every time the user inputs, our program is constantly going to be looking for all of these And if it doesn't find it, it's going to say no command found. And it just goes back up to the top and starts again, like a terminal in an operating system would. And inside these if statements, we run the command. So we do the if PID is equal to 0, the exec L, the else, and the wait PID. This again is how child processes and father processes run. Inside here is the child process, and here is the father process. The father will wait for the child to execute before executing himself, when the PID changes and everything. And that's basically how it works. You have the child branching off and executing its own thing. This exec L is executing the commands found at these pathways, which is basically the pathways where the actual commands are located inside a real terminal, even though this is a fake terminal. And then these arguments here, we have the command and we have the possible arguments and the optional 0. And it's the same for all of these, as you can see here. It's the same basic structure. We don't really need to change anything aside from the command that's being executed. So we have the PWD. These are without arguments, by the way. They don't need them. And once we get down to the bottom, we just go back up to the while loop again, because this loop is infinite. So that's the basic explanation of the code. Now let's see it in a little bit of action, if I can. And so we hit WQ to exit out, and we're back here. Okay, so G plus the code, and then the output. So we want to put the output, and we want to display the output like this. And we get this. This is a little bug I haven't figured out yet, but yeah, so and it does take a second to get started. But once I do it, you can see the PWD shows this. And yeah, that's what PWD executes. It shows you where you currently are in the system, and that's where I am in the system. This is actually the only place in the system. So if I were to do ls, it wouldn't do anything, because there's nothing here. Like that. But, yeah. So that's how the code works. It's very basic shell code, but it operates in the parent and child format, and for the most part it runs a basic operating system pretty well.